Good afternoon. Welcome to the QCIS channel. On this channel, you get a daily dose of science, technology, engineering, and math. My name is Leon Jones, and what I'm going to perform for you is an ADA ramp inspection. Now, before I get into the inspection, I'm just going to let you know what tools I will be using for the inspection. Now, down below this orange piece of equipment, it's called a measuring wheel. Now, how I handle the measuring wheel, I unsnap it. I set it back to 0. And what I'm going to do, I'm going to take a measurement for you. And it's very important that I take a measurement. Okay. Again, let me set it back to 0. It's at 0. Now here's how the measuring wheel works. I'm going to take a segment, the measure of this sidewalk, and go from here, and roll it out to here. And you see I come up with 4 feet 3 inches. That's how you use this measuring wheel. Again, I'll show you again how to use the measuring wheel. I'll measure this line of curve. That's how the measuring wheel is used. Okay? And I come up with about 10 feet. Now it's very crucial how to use this piece of equipment, because for distances longer than 100 feet, I don't want to go and spread a measuring tape out. But now I'm going to show you the measuring tape. This right here is a measuring tape. It's 300-foot measuring tape, and I'm going to show you how I'm going to use this. Now, measuring tape, and this is about 300 feet. Put my foot on this end, and I'm just going to do a little bit of measuring. All right, here's how you use the measuring tape. Now, all the way from the end of the curve to where my foot is. The foot's at 0. I get a measurement of 2 feet 7 inches. Here's how I use the measuring tape. Our measuring tape I use for shorter distance. Now, something else you need to understand too when I'm doing this inspection. This right here is a smart tool. Now, the smart tool is used to measure slopes. Now, what I'm doing out here is looking at an ADA ramp. This whole section is an ADA ramp. This area right here is known as truncated domes. This is for individuals if they're blind. Before they walk into the street, they will feel these domes. These are truncated domes. Generally, the detectable warning surface is about 2 feet by 4 feet. But what I'm going to do with this tool right here, the smart tool, I'm going to turn it on. And what I have to do with the smart tool has to be calibrated. So the way I calibrate this smart tool is I put the smart tool down. All right. And then basically when I calibrate it, I hold it. Calibrate, you hit calibrate, you calibrate it. And then you hold it when you get your measurement. And you also have your signal there, up or down. But this tool right here is very important, because what I do with this tool, I measure the slope. So I put this tool down, and what you're going to get a slope with this part of the wall. This is the ADA ramp. Put the tool, and I give you a cross slope. That's how this works. And basically what I'm doing, I'm going to be measuring all the ramps. And once I measure all the ramps out here, I actually put it on a sketch. And as you see, I've already sketched it out. And I've sketched it out, it's not drawn to scale, but I've sketched it out to look like the sidewalk. You can see this circle right here. This is the stop sign. And this circle right here, this is your manhole. So what I'm going to do right now, without any further ado, I'm going to get a couple of measurements for you. And these are going to be slope measurements. So first of all, I'm going to go right down here. All right, this is actually happening too. Okay, as I put the tool down for this small piece right here, I got 1.5%. 1.5%. So when I get that, I write in here 1.5%. And that's from here to here. So what I'm going to do, I'm going to measure this surface right here with my feet. Now, shortcut, I can do this. All right, because I want to get the length and the width of this truncated dome or detectable warning surface. A shortcut, without measuring, this is a 2-foot smart level, so I'm going to go 2 feet, and I'm going to go another 2 feet, and the width is 4 feet, and generally they're 2 by 4, and I'm going to go another 2 feet, and there's the width, the length and the width. So what I've already done, I've already measured, if you see me write the numbers down, this is 4 feet here, and this is 2 feet in this direction. I'm gonna go back for this right here. This is your stop sign. So I'm gonna go ahead, because you gotta sketch everything out. I'm gonna draw my arrow. It's not drawn to scale, but this is the stop sign. Over here, I'm gonna go get this right here. This is the manhole. Could be a sewer, so I'm gonna write MH for manhole. Okay. Now that we have that together, I'm going to take some more readings here. Let me make it legible, because this is my sketch. When you're out here doing an inspection, you have to make sure you get all your information in. So I'm going to go right across the sidewalk here. This is the sidewalk right here. And that reading you get is 1.6%. That's the sidewalk. Now, I took that measurement right here. So I go, you gotta draw your arrows. And this is the engineering part. And I got 1.6%. That's the sidewalk. Okay. Now, what I'm going to do is I'm going to get this measurement right down here, this slope. So this down slope as you see it, that's the down slope. It's almost flat. It's 0.1%. Once I get that 0.1%, we call it 0.2%. It's almost flat. What else I'm gonna get? I'm gonna go ahead and get this. I'm gonna get this slope. Always got to get the cross slope. This is actually a ramp right here. So on this measurement, I got 0.7%. So I'll go ahead and write 0.7%. Make sure my numbers are legible. And then I'm going to come this way. On this section, right by the stop sign, and I got a 3.2%. So coming in this direction, I got a 3.2%. Now I'm going to go ahead and get the cross slope of this sidewalk. As you see, it's about 2.2%. And this is how this works. So I'm going to draw my arrow here. And this is actually live, so you can see all the information that I'm conveying. 2.2%. And that's all the information that you've all seen me get. You've seen the manhole, you've seen the stop sign. Now right here, this is a curb. Now when we deal with ramps, we're going to find out where our location is. So we're looking north, and when we look north, I put what we call a north arrow. So this is north. Now when we deal with ADA ramps, we look at where we are from the north. Okay, we go in quadrants. Okay, north, south, east, and west. So right now we are in the southwest quadrant. So we call this the southwest corner. This is the southwest corner. And how did I come up with that? Because if I'm looking up, I'm looking north. I'm looking down, I'm looking south. But I'm not due north or due south. So I'm either going to be northeast, northwest, southeast, or southwest. So looking down, I am southwest. Now, after that, what am I going to do? I'm going to actually take this wheel. I have the tape. Tape takes a little long. So I'm just going to measure the sidewalk. So I'm going to take what I got here. This is the measuring wheel. I'm going to set it back to 0. And then I'm going to start. And then I'm going to wheel it off. And get the numbers. I got 7 feet 2 inches. Which, when I convert inches, that's 7.16 feet. And that's this distance right here. S 7.16 feet. We've already gotten this distance. That's 4 feet. Now, something else I can do too. I wear a size 12, so I'm gonna take a shortcut. I'm gonna go 1, 2, 3, 4. Measure 4 feet. These are little shortcuts you can take. This right here is also 4 feet. Now, I'm gonna take this wheel. Every time you start a new measurement, you gotta set it back to 0. All right, that's at 0. So what I'm doing, rolling it out. That's how I'm taking my measurements here. And I got 10 feet, 9 inches, which 9/12 is 3/4 of a foot. So when I measure this from here, it's my dimension line, and this is my dimension line. I'm measuring here, and I'm measuring here, which I already did. There's my dimension line, and I got 10 feet 9 inches, which is 10.75 feet. These are the actual real numbers that I'm putting in. Now, some examples of some work that's already been done. This is some examples of some work that's already been done. Got the slopes, everything. And we just want to make sure that everything is consistent. Now I'm going to go get some more slopes. Make sure we have everything, because the slopes are the most important. I'm going to get the slope 1.7. 1.7, and that's for this little piece right here. 1.7%. That's the slope. And we're gonna go, whoa, little windy out here. That's my sketch. Put my sketch right here in the truck. And this is documentation. I'm gonna go ahead and measure this piece right here. Take the slope. And I got about 0.9, roughly 1%. Now all these ramps are not the same. So you go ahead and get all the information that you need. Because this is documentation. I'll go back and get this slope. And that's right around 0.9%. And this is an actual inspection being done too. Take a look at it. It's going across here, 0.9%. You can see all the numbers get a little discombobulated, but I want to make sure that everything is measured here. Now, the only item I have left is to get this piece right here, this panel. So, follow me. Go right here. Here's the sidewalk. 1.3%. And if you want to be an engineer, you have to draw sketches. Now, that's all the slopes I have. So now I'm gonna take it. Let's get the distances now. As you see, it's quite a bit of work to even do one of these. So I have to get everything. You get a measuring wheel, it doesn't stick. They actually go backwards. So I'm rolling it up my leg here to make sure that I get it back to 0. Or put it right against the truck here, shortcut, and set it. Set it and then forget it. And then measure it. And I come up with 16 feet. This is how this is used. This is actually better than using the tape. Tape takes a long time. 16 feet. That's from this corner to this corner. Now I'm gonna go from here to here. I'm gonna take a little shortcut here. So I'm gonna take my smart level, which that's 2 feet. Put my foot here. That's 2 feet, so we have 4 feet. Put my foot here. That's 2 feet. And that's a half a foot right there. Or I'd say one, let's call it half a foot. So we have 6.5 feet. And this is 6.5 feet. Always draw your arrows. 6.5 feet. We have this, we have 16. Now we just have to go 2 more feet. Basically, very difficult to do a radius. So what I'm going to do, I'm going to come out here. That's 2 feet. And call that 4 feet as well. And that's getting this radius, and that's to this detectable warning surface. That's another 4 feet. So overall, this dimension is 12 feet. Overall dimension. So we have 16, 12, excuse me, 6.5, 10.75, and then we have this sidewalk up here. And when you do an inspection like this, you have to make sure that everything is precise. And of course, you always have to draw a sketch. Now, again, my sketch isn't drawn to scale, but it's enough for you to see how I got the information. Again, to get the information, I use this. This is known as a smart level. It gives you slopes. I have my tape measure, which I didn't use during this inspection. I just showed you how to use it, and my measuring wheel. And that's how you measure an ADA ramp. And that concludes this topic on ADA ramp inspections. If you like what I just presented, please comment, share, and subscribe. And if you're looking for some social content, check out the 401 Talk Zone radio show on YouTube. Now, if you can't find the 401 Talk Zone radio show or the QCIS channel on YouTube, you can check both of those channels out on Twitter. Now, since the QCIS channel is more of a professional channel, I I take it one step further, and I put that channel on Twitter. And again, thank you for viewing this video on ADA ramp inspections. And thank you for viewing the QCIS channel as well. On this channel, you get a daily dose of science, technology, engineering, and math. Until next time, my name is Leon Jones. I want you all to have a wonderful and gracious day.